Welcome back, dear students. In this video, we are going to be discussing about contract storage. What is contract storage? What is it used for? How can you make use of them? And a lot of things like that. Now, as usual, we will try to compare it, focusing on Solang, then Solidity, and how any differences or similarity. Also for vanilla Solidity for EVM or Ethereum. Now, the first thing, when you talk about contract storage, is the default, the memory. Let's look at it like you have a computer, then you have a ROM, and you have a RAM. So in the previous lesson, I mentioned something like that. The ROM of your smart contract, that directly stored on the blockchain, is in Solang is called the contract storage. On the vanilla Solidity is also referred to as storage. So that means whatever you store in contract storage is persistent because it's on the blockchain. It's not temporarily like you have it on a RAM now. You have your PC is on and then your RAM is saving some things temporarily. If you are working on a Word doc, for example, and you are typing and you didn't save it into the RAM, it's just temporarily displaying there or in the ROM. It's just temporarily displaying on the RAM. Then if suddenly your system for whatever reason goes off, then you instantly lose whatever is there. So it's the same thing, but if it has been saved in the ROM, then even if the system goes off, as long as your hard disks and all those things are still okay, you'll be able to retrieve it. So as long as the blockchain still exists, whatever you have stored inside the storage will be there and accessible. So that is why you need to understand the difference, because contract storage is usually expensive because you are storing on the blockchain. But there are sometimes you are using other things like memory and things like that, which are temporal, like RAM. So let's have some features. The contract storage initialization. Initialize to 0 or false if not set. So in Solang, if you don't set it like this now, the value is like 0 if you don't set it up. So it default initialize. So for example, if I want to initialize this like we use in using our constructor, remember that's why we learned constructor. You see this, it says immutable variables can only be modified in a constructor. So if we want the storage, for example, to change into something, but we don't want it to be changed again later, then the only way we can do that, because we won't have any function to change it or do things like that, is to set it up using our constructor at the point of deployment. And once it's set, we won't be able to change it later. And the reason why we need to set it inside the constructor, remember, is that by default, it will be 0. So if we need a value there, we need this now, this is 0, we need it to say, no, it can't be 0. Let it be Fosky, or let it be a wallet address, let it be something like that, or whatever it could be, so that it sets the state before the contract then starts working and things like that. So you need to keep that in mind when using the contract storage. Then accessor function. What is the accessor function? Anything you declare here, for example, usually come with an automatically created accessor function. And because we are using our Anchor, it's not as easy to test some of these features. So let me test it for you since it's the same on both vanilla. Let's use this IDE. It's much easier because you can easily deploy and test the smart contract. So let's have this. We have this storage now. Let me go here and deploy it. Now you can see this is what is called accessor we are looking at here, assessor functions automatically generated for public variables. So for you to understand it, you will notice that this number, you can see it now, this number, you don't have anything like number here, but when you look at this, you have the mapping as well. Then you have the function 1, which is this store, then function 2, which is retrieve. So what this does is we have this number, this is mapped as a balance. Then you can use this to change that number, which is this uint, this number, you can use it to change whatever the number is. Then this particular function, you can use it to retrieve. So for example, let me retrieve is 0. So that's what is being said here, that if not initialized, maybe through constructor or something, it will be initially defaulted to 0. So that's what happened here. You see retrieve and is set as 0. Now let's try to add a number here, 1, 2, store it. See, there is a transaction here that was successful. Let's retrieve it back, then it's now 12. If I put this as 5, 6, store, this is just a basic contract that store and it override it each time. So let's retrieve, and then you see we can retrieve whatever we have here. So that's this. Now what this aspect is now saying is that the assessor function automatically generated for public variable is this. This storage, this number now is seen as a private, so it's only available to be called in the smart contract and things like that. But if you want it to be also public, accessible for check, then we can just put public. You see it? And now let me redeploy this contract. You see this? Instantly, this creates the number. Can you see it? And when we check it, is 0. If I add numbers here, store, and check it, you see it? Similar to the function. You can see it now. So this is like it automatically generated a kind of this type of retriever, or we have learned about setter function that changes things like this, and retrieve getter function that doesn't change anything. So it instantly sets a getter function, which is also known as the assessor function. It's just to access the information. So I hope you are able to. Don't forget, if you have any question, get confused, always head straight to the community, Discord community, to get support. So that's what that is. And the same thing works here. You can have this as public, and you see it has no error. You can as well have it as private to explicitly state it that this shouldn't be accessible outside the contract, for example. You see it? So the same if I change this also to private. Then I try to redeploy this the third time. You see that it's not there, but we can still retrieve, we can still save. So it's because it's uint, I can't save string. So let's save this, store, and then retrieve. Can you see that it's working now? So do you see the differences between them? Yeah. So we have the array and mapping assessors, same. Key or array indices become argument. So for example now, I think if I try to make this mapping, I think I should be able to, let's try public. Oh, sorry. So I try to make this public. Let's see if it's compiled so there is no error. Let's try to redeploy again and see what happened. We have another one here. Can you see it? Balance. So we want to check. So what this is saying is that when you put this same public, for example, inside a mapping or an array, it turns whatever, this mapping now is mapping an address to a value. I discussed it earlier, key value pair. So this is an address, then it's mapping it to the value that address holds. You understand now? So the value that address holds, you can see it here. So if you want to check this, you need to put the address here to check it balance. So I think we have the address we used to deploy, for example. Let me put it here. Let me try and change this and put like 7 and see if it will work. You see, there was error, it's displaying nothing. But let me put the actual address and let's see. Do you see it? That was able to retrieve. So at least that gives you an idea what this accessor function is about here. Like this. It's just come up once you have public or something like that. So it gives this because it's just a variable. But if it is something like mapping or array, then whatever this like address, you can now take it up from here. You put the address and then you'll be able to get the value mapped to it. This wasn't actually showing because this is a basic contract. It wasn't organized or written that way. It's just a sample contract, but that's what you can do. You can use this address to retrieve the balance of the token owned by this, created by that smart contract, and some other values like that. So these are what the mapping array, accessor, and all those things. Then overriding base contract method, possible with override keyword. So you can override the contract method with the override. What this means is that we'll still see when we are actually dealing with our live ERC20 token and things like that. When you inherit another smart contract and they have the same function, but you want to adjust something that is not in the general one, you want to customize that function to your own. When you use that same function you used to use, you have to use the keyword like here, override. Once it's still the store, you should take this to override the one imported and execute this instead of the imported function. So that's what that aspect is about. Then clearing storage, it's not that easy to do. So, but there is a keyword delete that could be used, but costly for multiple primitives. So that's why you have to be careful what you save, what you keep in the storage, the contract storage, because actually it is costly because you are actually saving on the blockchain itself. So not everything you should just save directly using your smart contract through to the contract storage. That's it for this section. You can always check, go through the exercise, go stock. We always have help for you available to support in the Discord community, so check it out, and I will see you in the next lesson. I remain Solomon Foske. Keep the programming spirit high and alive, your assurance to succeed in the long time as a developer. Peace and bye.